Hello, friend. Today is Sunday, and I am welcoming you all to discuss something very important related to science. And since I'm live, you can actually interact with me. And if you have any questions on this subject, you are more than welcome to basically send in your comments. So, the topic of discussion today is when we are looking out using our telescope into outer space and trying to explore the nearby solar systems and trying to find out if there is anybody else other than humans around, any other type of life forms which exist, so that we can prove that we are not the only one in this vast universe. There are many living organisms, different kinds of civilizations that exist, uh, either in the close by vicinity or even far off, anywhere in our own galaxy. Well, our technology is limited to exploring about life in our own galaxy, but I'm sure there would be life forms in other galaxies which are far, far away. But nevertheless, let us look at what is our methodology today to explore these life, and that is largely dependent on the kind of life we think ourselves to be. We think that we are carbon based life form, oxygen breathing and water drinking life form, and that is what we feel that the other other life forms will be similar to that. And that therefore we are debating the whole concept that whether we should be looking at that or we should be looking at some other parameter, because you may be, if you are restricted to only looking at trying to find life which is similar to us, then we may be missing out on the civilizations which may exist, and therefore we may overlook the science. So the topic of discussion is to basically understand what is going on, how we can increase the boundaries of our exploration and identify if there are other kinds of civilizations which are absolutely different than humans as we know our biology, etc. So when we look around, we actually look at our current method of looking around is basically looking at the habitable zones. And we know exactly what are these habitable zones, because these habitable zones are, as far as our exploration is concerned, are the areas in the solar system where liquid water can exist. That means the temperature in that zone, in that belt, in any solar system is conducive for liquid water to exist. That means the temperature should be around 25 to about 50 55 degrees on the surface of that planet within that zone. So first of all, how do we, because when we're looking out in the solar system, we are looking at other solar systems using our technology, whatever technology we have, like telescopes or radio telescopes, etc. So it's quite difficult to look at signs of life. Therefore we have divided, we have come out with this matrix where first look for the habitable zones, and if there are any planets within those habitable zones, then there could be a chance that liquid water exists on those planets. And when the liquid water exists on that planet, there could be chance of life, because as we know that water is very essential for life to first of all kickstart the life, and then also create various permutation combination when it comes to when we talk about natural selection. So water is the best medium. There could be other mediums also, like methane, liquid methane, etc. So we will discuss about all of those things. However, liquid is very essential. You cannot have chemistry for life in solids, or even if it is there, it may take eons for that chemistry to take shape and for natural selection to take over. The process of life will be very slow when we talk about solids. So if it is liquid, then the chances of creating complex life is much higher, much better opportunity. And water is quite abundant, so our study at the moment is basically look for water within the habitable zones. Now let's look at this diagram again. These habitable zones are basically derived from the on the basis of the size of the star. If the star is pretty large, then the habitable zone will be far off from the star, because star is churning out so much heat that um, if the planets are close by, then water will evaporate and it will completely the planet will be very completely barren. So the habitable zone where the temperatures are conducive, similar to what we have on Earth, then the habitable zone for a large star will be outwards in the solar system, because that star is big, churning out a lot of heat, and hence the habitable zone is quite out. That means the orbit around a large star for a planet which can harbor life will be quite long, and the year will also be quite long. Now, sun-like star is very similar to Earth. We are at a in our position where liquid water exists on Earth, and because of that, the life also exists on Earth. Although we have not done enough study, and I think that is why studying Venus, studying Europa will be very important for us to basically identify if there are other kinds of life system that can exist in the universe. For example, Venus will offer an opportunity where in high heat environment there could be some sort of life that can be existing, even though it is even microbial life, it is okay, because that will give us some direction that life can exist in even hot planets. Similarly, if you go to other end of the spectrum within our own solar system, we need to identify if there is life existing at Europa, because the mean temperature there on the surface is about minus 150 or minus 200 degrees. So if life can be found on Europa, because even Europa has a very similar geology like Earth. However, the temperatures are so low, there is no water here. Whatever water is there, it is rock solid. Water probably in such low temperature behaves like granite. However, on surface of Europa, there are oceans of methane, and there is a circulatory system very similar to Earth, but the methane evaporates, condenses in the sky, fall as methane rain, and then there are big oceans, big lakes, and the methane rain and the methane cycle actually creates the same geology as we see it on Earth. So as far as geology, nature, etc. is concerned, it's very similar to Earth. There are mountains, there are rivers in which methane is flowing. However, we have to still study whether Europa cold bodies are able to harbor or create or kickstart life, and that will give us a good ballpark where we should be looking for life in the first place, using our old method of identifying the habitable zone. And last is the cooler star, which are typically red dwarf, where the habitable zones are quite close to the star, and that creates another scenario where the planets are too close to the star, and there could be eruptions coming from these red dwarf. And since the planets are too close, then the gravity might take over and then tidally lock the planet to the star. That means only one side of the planet will always be looking at the star at all time. That means there will be a perpetual forever daytime, and there will be perpetual forever nighttime. So that creates another complexities. So when we are looking for habitable zones, this is what we understand so far. However, the scientists are now saying that any kind of intelligent life, even though if it is in habitable zone, is able to come up. They will definitely come up with some sort of a computational power. Even if there is some sort of species which has become intelligent on a water world, even if in the habitable zone, then they will start looking at generation of some sort of computer, because in order to do complex jobs, you would need to come up with some sort of computer. And the scientists are saying that we should look at science of computing zones, where the computation is possible within a solar system, rather than looking only at the liquid water, because liquid water may be limited to habitable zone there, but the computational power can be extended to other parts of the solar system. And if we are not looking for the computational ability and just keep looking at the water, then we may be looking out or we may be missing out some sort of intelligent civilization which is not very similar to us, or maybe may have evolved in a different manner. However, they have become intelligent and they have the ability to basically compute numbers, create complex machinery, and also create different kinds of artificial intelligence type system, which creates further automation. And if we look at the science of those kind of zones in any solar system, then our area of looking around using our observation, using our telescope, will be much wider. So we should be looking beyond the habitable zones that we understand. We should be looking beyond the planet in any solar system which has liquid water, and we should expand our horizon and start looking for the computational zones. So scientists are now calling this area as computational zones. Now, even if you look at the Earth, also we have computers, we have all kinds of automation, but the biggest information that can be stored is in the DNA. DNA is a natural compound which can store lot of information, and DNA can also be programmed. When we say that we have the ability to change the DNA, is simply because we now, based on our understanding of the gene, we can actually alter the gene. That means we can compute and change physically what is to be needed. Sometimes these permutation combination can also in fact it's all the time, it is done by the nature. So it's a natural process where using different permutation combination, the DNA keeps enhancing, improving, and that is what creates the natural selection. So DNA is a natural computer. So maybe we should look at this kind of chemistry happening, not merely looking for water as habitability, as a parameter for habitability. We should be looking at if there are natural molecules available which can be programmed or being programmed by the nature, just like we have on Earth in the form of DNA, because DNA can actually host lot of information, and it even if after millions of years you can decode the DNA and then identify what kind of animal this DNA belongs, what could be his or her its characters, what could be the color of the skin, what could be the color of the hair, etc., etc. So all of that can be identified, and since it exists in nature, the DNA itself keep evolving based on natural selection, and keep improving the life form as and when situations becomes favorable or adverse. In both the cases, DNA will basically get reprogrammed, and the future generation of that organism will try to adapt to that natural condition. If the water reduces, then your ability to store water within your body increases, and that is all done by the DNA. So DNA basically keep storing that information, and also has the ability to reprogram itself. So it's a natural computer. So when we talk about this natural computer, obviously the molecules it's a chemical process, and these molecules must be happening, or the chemistry involving the similar molecules like DNA may be happening outside the habitable zone also. So when we look at James Webb telescope and try to look for signs of other civilization, maybe we should expand and start looking in the computational zone where this kind of permutation combination is being looked at, and probably we can start by exploring outer regions of our solar system, start exploring bodies like Europa or Titan, where as far as we are concerned, life cannot exist because it's very cold there. So maybe we can find out if these kind of molecules or chemistry is going on in that part of the solar system, and that will give us a clear picture whether based on this computational power where the life can exist, because that will also expand, that will open our mind, that will also give us more input in terms of identifying different type of life forms which we do not consider as life. Maybe there could be life form who has a very long metabolism. That means we live for 100 years, probably we have a Jedi kind of lifespan where the species lasts for 1,000 years. So for first 200 years they will be still juvenile. So the metabolism of these long lasting species may be very long, and when we look at them we think that they are not living at all. So because their metabolism is so slow. So this kind of study will help us improve our ability to increase our area or our exploration and start looking for computational zones, and that is very important, where there is some sort of computation going on. And this also gives us an ability to identify that nature can also become a computer, a natural computer, like in the form of DNA. So, like we have DNA as a core building block of life on Earth, every organism on Earth has a DNA. There could be similar molecules which we have not yet identified on Mars, on Venus, which may have a totally different origin. They may be similar to DNA, not exactly like DNA, but similar to DNA. They will have the ability to make a copy of themselves, just like DNA. But when we look at them, they are not anything to look at, just like DNA. But they have the ability to store the computational mathematics, different codes, and then become part of natural selection. So I think looking at this computational zone in future, in outside solar system, outside world, will give us better chance to look for other alien species, other advanced civilizations, other intelligent species, even within our solar systems and also outside our solar system. So this is something that I thought I will talk to you today: how humanity can expand their horizon of exploration and try to identify other species which are absolutely not similar to what we know about life today on Earth. All right, so if you have any comments, friends, feel free to send in your comments, your suggestions. And as always, thanks for watching. I will catch you in the next one. Until then, have a nice Sunday. Bye bye.